Hey everybody, this is Larry. This is me going over Q4 of the Leetcode contest, maximum palindromes length from subsequences. So this one turns out to be dynamic programming, and I had a little bit of trouble doing this because I thought Q3 was also dynamic programming, and it's just a little bit odd to have almost the same algorithm for both problems, but I could be wrong. There might be other ways to do Q3 or this one. So hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this problem. So for this one, n is 1,000. That's the first thing I looked at, and I end up gambling a little bit. I don't know how close I am to the TLE, but for me, I construct, so basically the idea is that you take this take a subsequence from word 1 and a subsequence of word 2 and then combine them and then get a palindrome, right? So what does that mean? That means that you want to match the end of word 2 with the beginning of word 1. So what I did was so that's pretty much the idea. So I combine them together and then use dynamic programming. And I want to say that this is a relatively simple recurrence. I'm actually a little bit confused whether maybe there's a better way to do it. But basically, yeah, you look at me, I go, so there is a trick that I'll go over in a little bit, but I have, length of word 1, word 2, but with dynamic programming, I like to go over the code directly because it allows, because it is basically the recurrence, right? So, yeah, so I have n1, n2 for word 1, word 2, and I concatenate the word, and then I, just have a new n, which is now 2,000 at most, and I just do this dynamic programming function where you can think about, just one character at a time, and this is a very common dynamic programming problem. So definitely, this formulation, once you're able to get to this point, it becomes a straightforward problem of concatenation, which is why I'm a little bit confused about the difficulty. But that aside, yeah, and this, you see this in longest common substring and stuff like that. But basically, instead of having two strings, you just got, from the left pointer and a right pointer, almost like a 2-pointer thing, but with dynamic programming. And then you go, okay, if the left pointer and the right pointer of the characters match, that means that you can take them out and then, do a recursion on the rest of the inside of the word. And, this is why we take two characters out here and we take off one character, and then we just see if that's the best answer. And in a way, we don't have to prove anything because of dynamic programming, you're brute forcing or possibility, right? Because this is the possibility of, okay, we have two characters that are the same, let's use them in our palindrome. And then here we go, okay, they may or may not be the same, but let's move our left pointer one step to the left, or one step to the right from the left. And this is the same thing, except for we move it from the right one step left to the left. So if you're familiar with dynamic programming with longest common subsequence and stuff like that, this will look very familiar to you, I hope. And if it doesn't look familiar to you, to be honest, I would recommend practicing one of those problems first, because they do come up all the time and they're fundamental. And that's the longest common subsequence. And then the base case is, if we go overboard, that means that we have no characters left. This is, 0 characters base case. So that's why the answer is 0. And this is a 1 character base case. And in a palindrome, the 1 character base case, we return 1 because this is the middle of the string. So that's why we have the base case. And this is pretty straightforward, to be honest. And I'm not trying to say this to make it sound, or to make me sound smarter, or if you didn't get it, to make it sound dumb. I think the hard part is the reduction of combining the words together to do one of this. I actually don't know if there's another intended solution. So if you're watching here and there's a better solution up to this point, then then I apologize. Then maybe it's not similar. I got lucky with the time limit, but I'm not sure. So I don't know. It's possible that there may be some linear time thing with respect to maybe the size of the alphabet, taking advantage of that. So maybe you could play some math there, but I am not sure. Not gonna lie. And as usual, you can always watch me solve it live after the cut. But yeah, so the tricky part about this problem is, or at least for me, is where is it? Oh yeah, here. Yeah, that each subsequence have to be non-empty. And what this means is that you have to have at least one character from word 1 and one character from word 2. If we look at the naive way of us doing this LCSE thing, then you're going to notice that, hey, we may return 0. We might actually, skip all the characters from the right word, or from word 2, and just use all the characters from word 1. And the way that I fix this, if you will, is just by it's just by adding 2 for loops, and I just trigger the starting point differently, so this condition requires that there's a character being used from word 1 and a character being used from word 2, and once we and this is just index juggling as a result, and we add 2 to kind of make sure that we use one character from each subsequence. And that's basically the idea behind this problem for me. I'm gonna make this slightly smaller so you can maybe take a screenshot. But yeah, so what is the complexity of this, right? Well, this is gonna be O of n squared, because left could be Kef. left is O of n, and right could be O of n as well, because it goes from where n is actually the new n, which is 2000, right? So yeah, so that's the time, and of course, and for each function call, we do O of 1 call, so this is going to be O of n squared. So yeah, so O of n squared time, and also O of n squared space, because of because there could be n squared possible inputs, and thus there could be n squared inputs, and each of them take over 1 space, so it's gonna be n squared. So yeah, that's all I have for this problem for now. I might add more if I and I do this trick just to make the indexing easier here. You could do the math in different ways, but yeah, there's some math here, but yeah, let me know what you think, and you can watch me solve it live during the contest after the cut. Bing. Oh, that all. I have to come back to it. This is silly. People already gotten this one, but okay. And there's 1,000, so it's probably some DP maybe. Yeah, this seems like just... No, is it? Yeah, I mean, it's DP. This is actually much easier. Oh, it has to be non-empty. I think that's the only tricky thing. I mean, yeah, it's a little bit weird, but it should be okay. Okay. I do remember this trick that my friend or someone mentioned, which is is faster, but is that even the right answer? I don't even know. I don't care if it's right, so let's go. It's gonna be time limit then. I don't get that one, maybe. Oh, This is a little bit tricky actually, because it could go from what? Really? Did I mess up? And that is just a silly mistake then. Oh. Maybe? Did I mess up? Okay, so why is it that I really don't know how to solve this. I might just eat it. This is going to be a terrible contest for me. I don't get it. It's m square. Why do they make it so hard? M is 1,000. Okay. This is going to be I mean, this is still n squared, but n is 2,000. So that's basically the thing. The thing that I'm worried about is something like, and then A, right? And then you want the longest is actually using from both. You have to keep track of it. This may be timeout too, so I don't know. But it's not quite right. I want this to be. Oops. Maybe it's going to be too slow. That's not great. Oh, I'm just being dumb. Okay. I mean, that was a legitimate bug though. That's going to be tight. Let's give it some minute. I don't think it's going to run though. But I don't really have any immediate ideas, so just a little bit YOLO. I don't get why they make the constraints so weird today. Okay, I have a wrong answer, so I'm wrong on that one. But that's the thing, is that even when I fix this, I don't know how I'm going to get it right. Expected for FEF, okay. I've been off by one somewhere. Oh, it's because I stopped reversing the string too, because I'm dumb. Okay, it's still wrong though. So many WAs and TLEs. 2,000 squares should be fast enough, but this is Leetcode and it's super inconsistent these days. Oh well, with a timeout I print stuff for sure though, and also run it a double time. Four seconds? Are you kidding me? This is a YOLO. I don't. If it works, it works. But that took a long time to even run just the wrong answer. But it's gonna get. I don't. Yeah. So thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, other problems, and I'll see you later. Bye bye. Also, take care.